Okay, there is one more measure that can be used to identify variables that have high multicollinearity. So multicollinearity is, remember, is among the predictors, okay, two predictors being very highly correlated with each other. Okay, sometimes it may happen that one predictor is highly correlated with a bunch of them. Okay, so here we are trying to figure out the a numerical measure that counts how each predictor is correlated with rest of the predictors. Okay, so this is how this is going to work. So here we're going to use only the predicted variables. The first thing to do is to get rid of the target. So in this case 13 and 14, cat.medv and medv, they will have to go. We're not going to use those. All right, and then this is how the variance the variance inflation factor is calculated. So let's look at it in PowerPoint. So here it is. Okay, so VIF is calculated with this formula for each predictor. So it's 1 over 1 minus r squared, where r squared is the coefficient of determination, which is SS, sum of squares of regression divided by sum of squares total, right? And this r squared is computed in a particular way. Okay, here what we're going to do is, if you want VIF of a particular predictor, then use that predictor as the target for the moment, okay, like the y value, and all the other predictors are regular x values, predictors. Okay, now run the regression, find the r squared. Okay, if there is no correlation at all, then r squared will be very close to 0. So that will be like a 0, and then the VIF value will be close to 1, right? So that's good, because this predictor has very low correlation with the other predictors. On the other hand, if that predictor has is highly correlated with the rest of the predictors, then the r squared is going to be high. So r squared, what is the maximum possible value for r squared? Maximum possible value for r squared is 1. So the higher the correlation this predictor has with the rest of the predictors, r squared will be close to 1. So what happens when it is equal to 1? If it's perfectly correlated, then this becomes 0, and this ratio becomes indeterminately large. So VIF values that are very large indicate that this particular predictor is highly correlated for the rest of them, and we need to get rid of this predictor. So low VIF means good, large VIF is bad. So what is low VIF? What is large VIF? It is kind of subjective. We can use somewhere around 4, 3, 4, 5, in that range is acceptable. Anything more than that, you have to be a little concerned. So how do we compute this VIF? Well, we have a library for that. Okay, and that library is called CAR, that is category and regression. That's what that stands for. So we need to run, install that library. So go to packages and install, and then run library CAR, right? So once that is done, then we can compute the VIF in this fashion. So we have to first run a regular regression with the predictors, okay, and all the for the target and all the predictor variables, like what we have done previously with LM. So let's say BH dot VIF dot reg. So we are now doing this for the purpose of VIF, right? So then we say LM BHDF, right? Um, So that's the, well, that we'll specify that at the end as data. So our target is medv, okay, and then we don't want tax, and we don't want cat medv, because cat medv is another target, which is the 0 1 target, okay, and then we say data equal to bh.df. Okay, so this is our regular regression, okay. And then once that is done, then we can run the VIF command, okay, or VIF function that comes from car with that regression result. So bh.vif.reg. So okay, so here I missed. We need to have a dot. So all the variables except these two. So that's the reason for the error. Okay. So now bh.vif. Okay. So here are the okay. Let's bh.vif. Let's look at what it has. So for each variable, so this has a VIF value. So that's good. So anything over 4 means, okay, so Knox has a high correlation. This is one of the variables that we got rid of earlier too. Okay, now it is when you compute VIF, it's a good idea to plot the VIF. Okay, VIF, okay, so we already did this, so I'm going to move that to near 0 here. A visualized picture of VIF is useful, so we can do a plot. Okay, so ggplot of VHVIF. Okay, and the aesthetic is, okay, let's look at what that is. So when we looked at it, so it has row names which are the variable names. Okay, so this has, if you view, you'll see view bh.vif. Okay, so this is a list. So what we need to do is we should really go back here and convert that into a data frame. Data frames are a lot easier to deal with. Okay, so change that to say, okay, so now we have row names. Okay, there is only one column here. Okay, this is 11 rows and one column. The column gives you VIF, so maybe it's a good idea to change the name, call names bh.vif. Okay, so and then the first name to be VIF. Okay, so then yeah, so these are the row names. Okay, so in the plot we want X to be the row names of bh.vif, and we want Y to be the VIF. Okay, so that's the VIF from this data frame. Okay, and the geom bar, now stat equal to identity. Okay, so So there you go. Now, okay, it'll be nice if you could. Well, suppose we want this to be vertical, so we can say coordinate flip. Okay, so that's going to print it this way. Okay, and suppose we want a line going like this to identify, that's the, 4 or more or less. So it's kind of a threshold. Okay, so we can draw a line. So that is geom H line. Okay, well, this will be V line, I guess, because it's a vertical line. And X intercept equal to, say, 4. Okay, let's see what happens now. Yeah, so this has to be vertical line. So, well, because we are doing a coordinate flip, this is, you do H line, and then that becomes Y intercept. All right, so then it will be, because of the coordinate flip, the H line will now become V line. Okay, so it's there, and you can change the line type if you want. So there is, if you Google, you'll see there are a lot of line type codes that you can use. Line type equal to, say, 5 will give you dash line like that, and then you can use a different color if you like. Color equal to blue. Okay. And you may want to print the VIF values for each bar. So geom text, right? And then AES is label equal to, say, we want to round the VIF value, say, 2 decimal places. Okay, and then we have to do H adjust, H justification is, say, minus 0.2. All right. So now that one is getting cut off, so we can have ylim, because we're gonna coordinate flip. So we use ylim even though it's on the x-axis. Okay. So now you can have a visual picture of which variable contributes more than the threshold VIF.